Hello everyone, so in this video we're going to go ahead and draw two appropriate Lewis structures for the species given below. The species here is C2H4O. So first we need to go ahead and calculate for the degree of unsaturation. So we'll simplify that to be DOU. So we have a formula for this. This goes half times 2C plus 2 plus N minus H minus X. So let's break this equation down a little bit. So C here represents our carbons, our N here represents our nitrogens, H represents our protons or hydrogens, and lastly our X here represents our halogens. So using this equation here, we can go ahead and apply this to our molecule. So we have again half times 2C. So according to our formula here, the number of carbons that we have is 2. So plus 2. Then our nitrogens here, we don't have any nitrogen, so that's just plus 0. And then our protons, we have 4 protons, so that's minus 4. And lastly, for our halogens here, we have 0, so that's just minus 0. Alright, so if I put everything into my calculator, the total that I get here is just 1, so we have 1 degree of unsaturation. So the given molecular formula corresponds to a structure with just one element of unsaturation, which can be a ring or a double bond. So to draw two appropriate Lewis structures for the given molecular formula, again of C2H4O, this is going to be consisting of three total steps. First being to determine the total number of valence electrons that corresponds to a given formula. So we can go ahead and sort of calculate this here. So starting off with my carbon atoms here, we see that again we have 2 atoms of carbon. Each carbon atom will contribute 4 total valence electrons. So 2 times 4 is equal to 8. So we get a total of 8 valence electrons coming off of just from the carbons. Next is going to be our hydrogens. We again see 4 atoms of hydrogen. Each will give us 1 valence electron. So 4 times 1 is just equal to itself. In our case, it's 4, so 4 valence electrons. And lastly, we have oxygen. We just have 1 atom of this. Each one will give us 6 total valence electrons. So 1 times 6, of course, that is just 6. And just adding everything up, 8 plus 4 plus 6, that gives us a total of 18 valence electrons in our molecule. So second step is to draw an appropriate sigma bond framework. 2 possible sigma bond frameworks with 1 element of unsaturation are going to be possible. So we can go ahead and draw that out. So starting off with our CH3 at the end of our molecule. Then we have, let's see, so we do have 2 carbons in our structure. So the only way that we have this oxygen here is a double bond oxygen, and of course adding the last proton there. And the next one would be a cyclic ring. So we'd have a 3-membered ring, 1 being oxygen and 2 being the carbons. So oxygen does like to have 2 bonds and carbon likes to have 4 bonds. So we can go ahead and fill up those other bonds with just protons or the hydrogens. Alright, so last step here is to complete the octet using lone pairs. We can see here that all the carbons and all the hydrogens are already fulfilled for their octet or their duet rule, but for the oxygens here, we see that they do each have 2 bonds. For the carbonyl group here, we have a double bond, and then for our cyclic ring here, we have 2 separate single bonds. So oxygens do like to have 2 bonds and 2 lone pairs. So we just need to add 2 lone pairs to both of our Lewis structures here. Once we put in those lone pairs, we have completed our structures for our species of C2H4O. So go ahead and highlight that as my final answer for this question.